Hello everyone. So today we will see motion under gravity. Okay. So we will study motion under gravity. So what exactly is motion under gravity? Suppose you throw a ball upwards. What happens? It goes to some height and it comes back. No. That coming back is due to the pull of the earth, or it is an acceleration imparted on the ball by gravity. Pull of the earth is nothing but acceleration imparted to the stone or a ball which is going up. That is going up due to some of the initial speed we have given. We give initial speed. Due to that, the initial speed it goes up. Then as it comes back, there is pull of the gravity or motion under gravity is what exactly it is. Okay, so hope all of you are here up for the class. Okay, that is motion under gravity. Hope it is clear to all of you. Now see, suppose if you are standing on top of a huge building, maybe huge building, so you are standing on top of that. Okay, standing on top of a huge building and you drop a stone. When you are releasing the stone, when you are just dropping the stone, you are not giving it any initial speed. Clear? You are not giving it any initial speed. You are just releasing it. You are dropping it. Dropping the ball. Dropping the ball or releasing the ball. Always remember, initial speed is 0. When you come across such words, dropping the ball, releasing of a ball, released ball, initial speed must be 0. Then what it does? See here, its acceleration due to gravity will act. Acceleration due to gravity will act downwards. Hope you understand. Acceleration due to gravity acts downwards. And the ball obviously would come down and it will hit the ground with the speed v, which we have to calculate. If h is the height of the tower, with what velocity it will come down, that we have to calculate. Okay, how to calculate that? See here. Here the displacement is along y-axis. No, if I take this will be y-axis, this will be obviously x-axis. So when it is coming down, the value along the y-axis decreases. So it is along the negative direction of the y-axis it is coming down. The acceleration due to gravity, which we denote it as g, is also vertically downwards. So by sign convention we take it as minus g. Why? Because it is coming along the negative y-axis. Because on a ball, acceleration due to gravity acts along the negative y-axis. This is positive y-axis. This is obviously negative y-axis. That is why it is taken minus g, and displacement of the ball is along from the top to the bottom. That is why it is taken h, and it is minus h it should become. So velocity with which it will hit is v square minus u square equal to 2as is the formula. Now v you have to calculate this v. Initial velocity, it is just released from top of the tower, so it should be 0. Okay, that should be equal to 2, acceleration is minus g because it is acting vertically downwards along a negative y-axis. Height is also from the top you are coming down, so it should be minus h. So the formula is v square equal to 2gh or v is equal to root 2gh. V is equal to root 2gh. That is a velocity with which it will hit the ground when dropped or released. When dropped or released from the top of a tower. When dropped or released from top of a tower. Is that clear? Okay. So this is one such equation. So the displacement is negative because it is coming down. Acceleration is negative because it is coming down. Then what about the velocity at a given instant? Suppose velocity, if I want to know v dash, what is velocity v dash here? From here to here it takes time t to come down. So velocity at any instant, from here to here it will travel in time t dash antare. At any instant t dash, v dash is minus gt dash agate. Using v is equal to u plus at formula, u is 0, a is minus g, t is t dash. Is that clear? Velocity becomes minus gt dash, where negative sign indicates the velocity is vertically downwards. The direction of the velocity is vertically downwards. Is that clear to you? Direction of the velocity is vertically downwards. That is why it is minus gt dash. Gt dash. Is that clear? Is that clear to all of you? So I hope these things are clear. Doubt idre keli. So let us have more of a interactive session today. Yes, any doubts? Okay, so then we'll continue. These are the two formulae. Okay, next, what about the displacement formula? If it is thrown from here, thrown down, released down, height is h itself, so the displacement is minus h is equal to half minus g t square. Time it takes to come down, let it be t antadre. It takes total time taken to hit the ground is t antadre. Then the formula is s is equal to ut plus half a t square. No, here displacement is minus h during the negative x-axis, negative y-axis. That is why it is minus h is equal to half. Acceleration is also due in the direction of negative y-axis. So it is minus g t square. So minus h is equal to minus half g t square. Minus minus cancels. H is equal to half gt square is one formula, implies t is equal to root of 2h by g, root of 2h by g. Root of 2h by g is the formula. Is that clear? Clear to all of you? So t is equal to root of 2h by g, h is equal to half gt square. This is one formula. So shall we solve some problems now on these formulae? Understood all of you? Any doubts? Any doubts? If yes, message the doubt. If no doubts are there, shall I continue? Please be interactive. Shall I continue then? Please be interactive. Yes? Based on these formulas, I think I can solve some more problems for you. Then we will see. Okay, how do you understand? Okay, so let us start solving problems. Okay. Write down a ball is released. A ball is released from the top of the tower, from the top of the tower, from the top of a tower of height h meters, h meters. It takes t seconds to reach the ground, what is the position of the ball at t by 3 second. At t by 3 second, what is the position of the ball at t by 3 second? So we can do this. A ball is released, he said. When ball is released, what about the initial speed? 0 it is. from a top of a tower of height h meters. So tower's height is h. Totally to come and hit the ground it will take t seconds. Total time of the journey is t seconds. So t is root of h by g. Then what will be its height at the end of t by 3 seconds? Okay. So h is equal to half gt square, no? H is equal to half gt square. Then somewhere I'll assume what is the position of the ball? So it's a displacement in t by 3 seconds. T by 3 seconds is y. So y should be half g t by 3 square. So you take h by y, half g cancels. T square by 9 is equal to 9. So h is y is equal to h by 9. So h by 9 meters from the top of the tower. From the top of the tower, displacement of the ball after t by 3 seconds is h by 9 meters. From the ground, h minus y now from the ground. It will become h minus y from the ground. Understood? Understood all of you? Okay? So from the ground it will be, from the ground it is at what height? From the ground it is h minus y, which is h minus h by 9, which is 8h by 9 meters from the ground. From the ground. I hope you understood this problem. This is CET level problem. Okay? Then you can do it. H is proportional to t square, correct? Then h by y is equal to t square by t by 3 whole square. That also you can do, as these two things are constants. Okay? Directly, one step answer you will get. But you look at the options. Now here intentionally I am not given the options. They might give you h by 9 from the top of the tower, or from the ground it should be 8h by 9 meters. 8h by 9 meters it is. Okay. How h by y came means I have to do it. There is no other go. Okay, I have to take the ratio somehow to find the answer. Options would be given to me in terms of 8h by 9, 7h by 9, like that. Okay. So, I'll explain again. Listen once. From the top of a tower, a ball is thrown down released down. So its initial velocity is 0. So it will hit the ground after t seconds. So what is the total displacement? H. Total displacement is h is equal to half gt square, correct? Then after t by 3 seconds it will be somewhere here, no? It will be somewhere here. After t by 3 seconds it will be somewhere here after t by 3 seconds. Getting this? After t by 3 seconds it will be somewhere here. So it should be y is equal to half g t by 3 whole square it should be. T by 3 whole square it should be. Is that clear? Clear to you? Understood? Okay, from the top of the tower its displacement is y. That is y. Clear? Okay. Now listen. Then I take the ratio, half g cancels, t square by 9 remains, 9 comes out, t square cancels. Then as I take 9 to this side, you have to be fast, h by 9 is equal to y, that is from the top of the tower. From the ground, its displacement should be whatever the remainder. This is h, no? h, no. So this, if this is y, then this must be h minus y. So the height should be 8h by 9 meters from ground. Understood? Understood? Yes, message not fast. I've explained twice now already. Understood, no? Any doubts? If you have message, please. Understood now? Okay, we'll move on to the next one more problem. Okay, next second question. Water drops fall. Water drops fall at regular intervals. At regular intervals from a tap 5 meter above the ground. 5 meter above the ground. The third drop leaving the tap at an instant when the first drop touches the ground. What is the height of the second drop? What is the height of the second drop at that instant? Options are 1.75 meter, B 1.25 meter, 3 C, option C 3.75 meter, option D is 3.25 meter. What is the height of the second drop at that instant? Yes. now we try this problem. Try, we will see.
Somebody asked me how t square by 9 got cancelled. Obviously, see, this is t square. This goes to numerator, no, into 9 divided by t square. So t square that is equal to 9. That cancels, no? Hope you understood.
Okay? In the previous problem, of course, in the previous problem, understood? Yes, you try this problem now. Try this problem. Difficult ones, I know. This is Comet K 2011 question. No other entrance exam. Comet K is there, no? Held by private engineering colleges union. Okay. See, first you calculate. Water drops fall at regular intervals from a tap. Tap is at a height 5 meter above the ground. This is a ground level. Here is where the drops going to fall from a tap. Drops are falling from a tap. So they fall down by 5 meter. Agree? Correct? So time taken by the first drop to fall to ground, time taken by the first drop to fall to the ground, fall on to the ground is the formula. We use same, no? H is equal to half gt square, or you can use t is equal to root of 2h by g, one and the same. Height is 5 meter, half acceleration due to gravity. G you can take 9 point, its value is actually 9.8 meter per second square. Okay. G value is 9.8 meter per second square. Okay, Aditya B, awesome it is. But from the high, okay, we will come to that, very good, we have tried it. G is 9.8, but for CET, NEET and all, for competitive exams, you can take G roughly as 10 meter per second square, okay. So what happens now, if you take G10, T square, 1s are 5s are, correct? 5 cancel. T is equal to 1 seconds it will take. Is that clear? So for the first drop of the tap, to fall on to the ground after the complete journey, which is 5 meter above the ground, it will take 1 second. Then what he says, the third drop leaving the tap, this is what he says, the third drop leaving the tap at an instant, the first drop touches the ground. So the first drop is here, this is the third drop. First drop is here and this is third drop now. And second drop should be somewhere here. So first drop T is equal to 1 second it has traveled. Correct? First drop traveled, T is equal to 1 second. Third drop has not at all traveled. Correct? So, since he says the drops are formed regularly, means time gap between the formation of the drops is equal. They are formed at regular time intervals. The formation of the drops on the tap, it should form completely, then it goes. Correct? They are formed at regular intervals. Correct? Water drops fall at regular intervals, he says. So this third drop has not moved at all. So the time of the motion of the third drop is 0. First drop is 1. Then average of these two should be the time traveled by the second drop. So second drop has traveled half seconds now. So correct agtade. Regular time intervals are managed now. Are you following? Regular time intervals are managed now. Hope you understand, all of you. So regular time intervals are managed. Is that clear? Regular time intervals are managed. This is about to leave, this is hitting the ground. So 1 second gap here. Then the second drop should have formed at half seconds after the first drop, half second before the third drop. Hope you understand. So second drop falls through height y. Second drop's displacement is y. Y is equal to half g. T is half g, half square. So it is, y should be half into 5 into 1 by 4. Sorry, 10. So it is 5 by 4 meter. So y should be 1.25 meter is the displacement of the second drop. Displacement of the second drop is 1.25 meter. But height of the drop, second drop should be h dash or capital H. Height of the second drop is, from the ground you measure height. No, not from the top you measure the height. From the ground you measure the height. So height of the drop is h minus, h it is, that is equal to 5 meter minus y, that is 5 minus 1.25, which is 3.75 meter. So option C is the correct option. I hope it is clear to everyone. Clear? Clear now? Is that clear to all of you? Okay, so very good, most of you have answered. So let us move on to when a ball is thrown upwards initially, then allowed to move under the gravity. Then when it is allowed to move under gravity. Okay. Isn't when a ball is thrown vertically upwards, when a ball is thrown vertically upwards, this is what we have to learn now. When a ball is thrown vertically upwards. So see here, standing on the ground, a person throws a stone or a ball vertically upwards with the initial speed u. With the initial speed he throws it, with the initial speed u. What happens? The ball goes up, reaches some maximum height and then comes back. No. Then it falls. He can catch it again. Understood? He can catch it again now. So as the ball goes up and up, then he can catch it again. Clear? Then he can catch it again. So now what happens here? See here. When the ball is going up, its speed is u. Its speed is acting vertically upwards. Acceleration is vertically downwards. But you want the ball to go up, but earth is pulling it down. Gravity is pulling it down further. Correct? Is that clear to all of you? Gravity is pulling it down further. Understood? No? Clear? It is pulling it down further. Now, still the ball moves up. At every instant there will be acceleration due to gravity. Then it reaches to some height where, because of the downward pull, this velocity, if I give initial velocity to this during throw, that's done. That's all. Correct? That's done. I cannot keep giving it initial velocity, but the pull will be constant throughout. So whatever the initial velocity I have given to the ball is being pulled down constantly by the earth. Constantly by the earth. That is why its velocity keeps decreasing with the time. So from here if you have thrown it, no, it reaches to some height here. So it takes, after time t it reaches here. After time t it reaches here. Then velocity here, let it be v. How do you find it? Velocity will be u plus at is the formula, correct? You have thrown it upwards with the speed u. Since you have thrown it with the speed u, it should be plus u. But acceleration is downwards, so minus g t. This is a formula for velocity at a given instant when the ball is thrown upwards against gravity. So at this height, at some height, after the ball has travelled upwards after time t, its velocity will be v is equal to u minus gt. U minus gt. It so happens, see, this gravity pull downwards is the decreasing factor of initial velocity. That is why the final velocity keeps becoming less and less as it travels more upwards. And it becomes less and less and less, and finally zero at a certain height. Finally the velocity becomes zero at a certain height. Understood? Velocity becomes zero at a certain height. And what do you call that height as? What do you call that height as?
maximum height reached. You call that height as maximum height reached. Is that clear? So you call that height as maximum height reached. So ಇಲ್ಲಿ ಬರುವಾಗ ನಾನು after time t it comes to this height. So this is v. Here velocity becomes 0. Then it cannot go further, no, because its velocity has become 0. Then suddenly what happens? Acceleration due to gravity takes over, coming down. Acceleration due to gravity takes over. So at a maximum height, you remember velocity of the ball is 0. I hope all of you understood. As the velocity becomes lesser due to the constant pull of acceleration due to gravity, here the velocity becomes 0. Here other than at any instant the velocity may not be 0, but velocity will be lesser than initial speed. Initial speed is u only. But as it goes to the height, during its ascendancy, during its upward motion, during ascendancy, its velocity becomes lesser and lesser. Is that clear? Its velocity becomes lesser and lesser. So v is equal to u minus gt. U minus gt. So at the maximum height, what happens? At a certain height, its velocity becomes 0. At a certain height, its velocity becomes 0. So 0 is equal to u minus g. I will write this as ta, because time t is for this height to reach, no? Now it takes more than t time. So the time taken is TA, I will write, then I will explain what exactly it is. So now GTA is U, TA is time taken to reach the maximum height is U by G, and we call TA as time of ascend. We call TA as time of ascent. Is that clear? We call TA as time of ascent. Ascent means time to reach maximum height, or time taken to reach maximum height during its ascending motion. So that is the formula. Any doubts? Any doubts in this? Message fast. You can message me fast. Message me fast. Srinidhi, ಕೇಳಿದ ನಾವು Clear?
ಎಂತ ಡೌಟ್ ಉಂಟಾ ಮಕ್ಕಳೇ? ಇಲ್ಲಲ್ಲ? Okay. So this is the formula for time of ascent. Time of ascent means time taken to reach maximum height after ascending journey. ಮೇಲೆ ಹೋಗುದು ಅಲ್ವಾ, ಆರೋಹಣ ಅಂತ ಹೇಳ್ತೇವೆ ascent ಅಂದ್ರೆ. Okay. Anyway, CBSE, ICSE students, so no need of Kannada. Okay. So TI is U by G. So V is equal to U minus GT is velocity of the object moving upwards. After time t, its velocity will be v. Its velocity will be v. Is that clear to you? Any doubt regarding this? No doubt, no? Clear, no? Okay. Next, what happens now? After this velocity at the maximum height becoming zero, it tends to come back now. It tends to come back and you can catch it again. You can catch the ball again. Because acceleration due to gravity takes over. What is the displacement of the ball? Tell me, what is the displacement of the ball? It is zero. So for the ball to come back, after time capital T, its displacement is zero. Vertical displacement is zero. So 0 equal to ut minus half g t square it will become. Which formula did I use? S is equal to ut plus half at square. Now, since it is thrown from the level and comes back to the same level, goes up and comes back, its vertical displacement is zero because its initial and final positions are same, no? After it comes back to the hands of the player, he throws it up, he catches it later. Later means after time t. He catches it. Correct, very good. Some of you have answered. Its displacement must be zero. Very good. So ut half gt square, because this is negative this side, no? So using this formula I can write, no? Ud plus half at square. So a is minus g. So it is minus half gt square ut. Clear? So half gt square equal to ut. T and t cancels off. 2u by g is capital T. This is called time of journey. Time of journey of the ball is 2u by g. That is a total time to go up and to come down. This is the time of journey of the ball. Hope all of you understand. Is that clear? Hope all of you understand this. Time of journey of the ball. That means the time to reach maximum height is time of ascent. Here velocity becomes zero. Then the downward journey is called TD. TD means it is time of descent. So also time of the journey is time of ascent plus time to come down. That is time of descent. Correct? TD we call it. From the maximum height to come back to the same level of the throw. That is called time of descent. Now we know time of journey 2u by g. Time of ascent we have already calculated. That should be u by g plus td it will be. So what is time of descent now? Time of descent is 2u minus u by g, which is also u by g. Now if you observe, time to go up and reach maximum height, and from maximum height, time to come down from the maximum height to the ground is the same. That is, time of ascent is equal to u by g should be equal to time of descent. Very important result. Total time of the journey is either 2 times the time of ascent or 2 times the time of descent. Is that clear? Any doubt in this? Any doubt in this? So, time of ascent should be equal to time of descent. Time of ascent should be equal to time of descent. Clear, no? Any doubts? Message. Understood now? All of you? Okay, now, no doubt, no doubt. Okay, thank you. Next, we shall see some formula, how it takes the form. Okay, we take up some formula. Or else solve a problem of this, okay? Solve a problem of this. One problem maybe can be solved of this. Then the formula for maximum height reached. So, see here, when you throw it with the initial speed u, this is a maximum height, no, where velocity becomes 0. So, maximum height reached is what we require, no. So, that can be calculated using v square minus u square equal to 2as. Here v is 0, correct? Because final velocity at the maximum height becomes 0. Hope you understand. Okay, here v becomes 0, that is at the maximum height. Initial speed is obviously u square. Then 2. Acceleration is due to gravity, minus g. So minus g. Displacement is maximum height. Correct? It reaches the maximum height. So called as h. M means maximum height. So minus u square equal to minus 2g hm. Minus cancels. Hm is u square by 2g. This is another formula we can use. Hope all of you got this. Okay? Hope you understand. Understood now? Okay, now we'll take up one problem. Then maybe we can conclude the class. Okay? Now take down a ball is thrown vertically upward. A ball is thrown vertically upward with an initial velocity velocity 19.6 meter per second. 19.6 meter per second. Find the maximum height reached. B, the time of ascent. C, time of descent. Yes, answer now. He says take G value, bracket he has given, take G is equal to 9.8 meter per second square. Yes. Shall we solve it now? See, its initial velocity U 19.6 meter per second. G is given to us 9.8 meter per second square. That is a pull or acceleration. Even on me, there is pull. That is, gravity is acting on me. Acceleration due to gravity is acting on me. You, computer, camera, bench, desk, tree, everything. Acceleration due to gravity is acting. On an average, it is 9.8 meter per second. Okay. Now, first question is maximum height reached. Formula is ready. It is ready to solve now. HM is equal to U square by 2G. U square is 19.6 square divided by 9.8 into 2G. So this is 19.6 square divided by 2 into 9.8 also becomes 19.6. So 19.6 cancels with this square. So the maximum height reached is 19.6 meter. 19.6 meter. Then what about the time of ascent? Time of ascent is U by G, which is also time of descent. If you neglect air resistance, we will talk about that in the next class. What is air resistance and all. So U is 19.6, G is 9.8, which is 2 seconds. So time of ascent is 2 seconds, which is also equal to time of descent. Hope all of you understood. Very good. Some of you have already done it. So nice. Sanjana, very nice. Good. So that is 2 seconds each. Time of ascent is equal to time to reach maximum height is same as time to come down from the maximum height. I hope you enjoyed the chapter today of motion under gravity. Still lot more to talk. We will solve more problems. As we solve more problems, we will understand it better. Okay. Hope you enjoyed the class today. Thank you. Let us end the session today. Thank you.